Hello friends, in our today's lecture we will discuss the direct form realization of IIR filters. Direct form realization of IIR filter is of two types, is direct form 1 and direct form 2. This is direct form 1 and direct form 2. Digital filter are basically described with our discrete LTI linear time invariant system. It might be represented in a block diagram form. The advantages of representing this in a block diagram form that it is very easy to visualize, very easily we can understand about our hardware requirements. Now, what are the basic building blocks of our uh, system? For basic building blocks for realization a system, there are three basic blocks. First one is adder, second one is unit delay element, and third one is our multiplier. In the adder, we just put the adder between the two signals and we got at the output x of n plus y of n. For the unit delay element x of n, whenever provide the unit delay element, we got at the output is x of n minus 1. Then we have a multiplier. If we want to multiply with some constant signal, then we got a of x of n. This is our multiplier signal. These are the three basic building blocks for representing our digital IIR system. Now the general equation for representing our IIR system is h of z, which is equals to yz upon xz. It might be written as bk z minus k is equals to 0 to n minus 1. These are the poles, these are the zeros and these are the poles. Now first we goes towards the direct form 1 realization of our IIR system. For the direct form 1 realization, firstly, as per the rule, firstly we realize the zeros and then we realize the poles of the system. If we have some h of z system function, then firstly we realize the zeros of the system for the direct form 1 realization, and then we realize the poles of the system. If we want to realize our generalized equation, this equation with the direct form 1, how we can realize? We can realize with the help of, for example, this is our x of n. X of n, here we can put over here is adder, b note is the constant term, then we provide the delay element z inverse, then multiplied by with b1, added with the in a previous term as per the generalized equation, then again z inverse, here the constant is b2, added in a previous term, and so on. At the end we have z inverse. Here we got x of n minus m, here we got x of n minus n, here we got x of n minus 2, right? And here we have b of m added in a previous term, then we have the uh, poles realization of our system. This is our y of n, z inverse, this is again z inverse, added a constant term over here, it is a1, a2, we can put over here multiplier. Further, this is z inverse, at the last we got y of n minus n. Here we put the coefficient over here an and added in a previous element. This is the generalized form of direct form 1 realization of our generalized system equation. Now we take one example, and on the basis of that example We will discuss the direct form 1 realization. For example, we have a question: h of z system function 7 minus 5.25 z inverse plus 1.375 z minus 2 upon 1 minus 0.75 z inverse plus 0.125 z minus 2. Now, as per the rule, if we want this in a direct form 1, as per the rule, we have to realize zeros first and then poles. For the zeros realization, we just put the z inverse and then z inverse, because z power is minus 2 over here. Put the coefficients over here: 1.375. Over here it is point of 5.25 with negative sign, and over here it is 7. Put the adder over here. This is the zeros realization of our system. Now we move towards the poles realization. For the poles realization, we have z inverse with 0.75. Here in the poles, we put the coefficients with the negative sign. Here minus of 0.75, we put over here 0.75. Then z inverse point of 125. Put the adder over here, and this is our direct form 2 realization of our direct form 1 realization of our system. This is the whole idea about the direct form realization of our IIR system. Now moves towards the direct form 2. In the direct form 2 realization, we firstly realize the poles and then realize the zeros of our system. For example, as per in a previous question we have a question h of z, which is equals to 7 minus 5.25 z inverse plus 1.375 z minus 2 upon 1 minus 0.75 z inverse plus 0.125 z minus 2. Right? If we want to realize the system in the direct form 2, then firstly we realize the poles, then we put the z inverse over here, coefficient 0.75, and then z inverse, put the coefficient over here is minus of 0.125, then adder, this is your x of z, poles realization. And then for zeros realization we have z inverse and then z inverse 1.375. The coefficient over here is 5.25, and over here it is the coefficient 7. The adder over here, and this is the y of z. This is the direct form 2 realization of our system. This is just opposite of our direct form 2. This is the whole idea about the direct form realization of our IIR system.